Okay, complex numbers, and we continue. But before we start on today's lesson, I'd want you to pause the video and answer these questions, please. Factorize and simplify. Then come back. Right, okay, nothing too challenging here, I suspect. A squared minus b squared, you spotted a difference of two squares, and you factorized a plus b, a minus b. And okay, and in the second question, simplify 1 over 2 plus root 3, perhaps you remembered that in order to rationalize the denominator of this fraction, and if you the purpose of doing this is to denominators are kind of a protected species. We don't like dividing by irrationals or negatives, or we like to have our denominators in as rational numbers or integers, or certainly as high or as low down the number food chain as possible. So yes, it's okay to have a numerator that's irrational, but denominator, nah. So how do we rationalize a term such as 2 plus root 3? When we had a simple 1 over root 2, then there was nothing much to it. We just multiplied by root 2 on root 2. That rationalized the denominator. When we've got two terms, if you remember, we multiplied by what's called the conjugate of 2 plus root 3, and that's kind of like the opposite term, 2 minus root 3. And the reason we do that is the same reason as we got this. If we worked back this way, the product of two conjugate binomials results in a squared minus b squared, that difference of two squares. So we notice here, and I'll just get my blue pen back out, that when we carry out this multiplication, we end up with 2 minus root 3. That just switches into the top, and the the denominator becomes 2 squared. Now the magic of this is that these two terms here cancel each other out with conjugate pairs, and we're left with we're left with a squared minus b squared. So a squared in this case is 4, and b squared is 3. So it's just 4 minus 3. So we're left with 2 minus root 3, which certainly is a simplification and improvement. So the reason I wanted you to go through that was just to bring back to the conversation this idea of conjugate pairs, what conjugate pairs are. So I'm just going to write this conjugate pairs. So conjugate pairs are binomials that just have the opposite sign in between the two terms. So conjugate pairs are well, they're a plus b and a minus b. They're 2 plus root 3, and they're 2 minus root 3. And, well, they're 1 minus I, and they're 1 plus I. So we call these, well, this is just a conjugate pair. This is a conjugate pair. We don't know what A and B are. These are conjugate surds. It's still a conjugate pair, but the product of them rationalizes. So it's a conjugate surds, and these are conjugate complex numbers. And we're going to spend a little bit of time today using conjugate complex numbers, because if you multiply conjugate complex numbers, let's see what we get. We get 1 minus I by 1 plus I gets us, well, 1 times 1. Now we know that plus I minus I are going to cancel out, but I'll write them down here just one time only, and then I get minus I squared. Now I squared is equal to negative 1. So 1, these cancel out, and I've got minus I squared, which is negative 1. So we end up with 2. So conjugate complexes, well, that makes a real number. So when you multiply conjugate complexes, you get a real number. When you multiply conjugate surds or irrationals, you get a real number. A rational number. My mistake. Sorry. Surds are real numbers, but what you do when you multiply the conjugate surds together, you rationalize. You get a rational number. So the same kind of idea with conjugates complexes, in that multiplying by the conjugate will make your complex number, it'll make it real. So if we rationalize for surds, well, we realize for complex numbers. So let's have a look now at some complex multiplication. Okay, so let's look at some examples of complex multiplication. I'll do the first one. Perhaps you would like to pick up B and C after I've done the first as an example. I always like you to watch the first one, even if you know how to do it, just so that you pick up, very importantly, how to structure your solutions. So Z1 times Z2 minus Z3. So Z1 is 1 minus 3i. Z2 is 4 plus I, so we're multiplying those guys together. Then we're subtracting Z3, which is negative 2 plus 3i. I need to take care of this multiplication first, so let's do that. And it's the FOIL approach. It's 1 times 4. We're picking up all 2 by 2. We're picking up the 4 pairs of multiplications. So 4 plus I. Now internally here I've got minus 12i, and then I've got this minus 3i squared. I'm going to now expand this out, so I've got minus negative 2, so I've got plus 2 minus 3i. Okay, let's just do a little bit more sorting here. I've got a 4 and a 2, so I'm going to put them together and get 6. I've got, actually I'm not going to do that. I've got to sort this I squared out first, so let's just deal with it. 4 plus I minus 12i. I squared is negative 1, so minus 3 times minus 1 is plus 3. Plus 2 minus 3i. So what do we end up with? I'm going to end up with a complex number with a real and an imaginary part. Let's get the real bit sorted out. 4 plus 3 plus 2, so I've got 9. And in terms of I, I've got I minus 12i, so I'm on minus 11 minus 14i. 9 minus 14i. Okay, so I encourage you now to have a go at B by pausing the video and seeing how you go. Okay. If you've got the answer to this, maybe speed me up to ×2 so that you can just quickly see how it peels off. Make sure you're not taking any shortcuts here. So Z1 times Z2, I've already worked Z1 times Z2 out. I've got it right here. So Z1 times Z2 got me 4 plus, minus 12i. Sorry, there. 4 plus I minus 12i, so 4 minus 11i. And then it was plus 3 on the end. So 4 minus 11i plus 3. That got me the Z1 times Z2. And then that was multiplied now by Z3, which is minus 2 plus 3i. So I've got 7 minus 11i by negative 2 plus 3i. So negative 14 plus 21i plus 22i, so now I've got plus 43i. Now this is minus 33i squared, minus 33i squared. I squared is negative 1, so it's plus 33. So minus 14 plus 33 is 19, plus 43i should be our result. Okay, now do the same with C and see if you can get C out by pausing and doing the question yourself. Okay, Z1 we're squaring here. So I'm taking 1 minus 3i and I'm squaring it. I'm adding twice Z2, so twice Z2 will be 8 plus 2i, and that is being multiplied by Z3, which is minus 2 plus 3i. So a bit of sorting out to be done. Now let's do this square. So it's 1 squared. It's twice the product of the two terms. The product of the two terms is minus 3i, so I double it to minus 6i. Now I'm squaring negative 3i. So negative 3i times negative 3i is 9i squared. I squared is negative 1, so 9i squared is negative 9. So that gets me through that square. Now I need to work out what I've got here. So I've got minus 16. I've got plus 24i. I've got minus 4i in here. And I've got plus 6i squared, with I squared being negative 1. So 6i squared being negative 6. Alright, so 1 minus 6i minus 9. Alright, so let's put our real parts together. 1 minus 9 is negative 8. negative 8 minus 16, negative 24. So I end up with negative 30 minus 6i plus 24 looks at 18 minus 4 is plus 14i. Okay, another example, and this is a little different. Find z, which is a complex number, that satisfies this equation. So z's complex. Right, so we can do a little bit of sorting out here. We just want to solve this. So z times 2 minus I. So that looks like 2z minus iz on the left-hand side. And I've got z plus 3 plus 2i on the right-hand side. So if I collect my z's on the left-hand side, I'm bringing this z over, so I'm going to have z minus iz on the left, and on the right I'm going to have 3 plus 2i. Okay, so therefore, if I factorize my z out, I've got z1 minus I equals 3 plus 2i. Now this looks to me like z is equal to 3 plus 2i dividing both sides by 1 minus I. There's my z. However, I would like to realize the denominator of this. So just as I would if I was faced with an irrational denominator, I've now got a complex denominator here that I would like to make real. So I multiply by the conjugate of my denominator, which is 1 plus I. In doing so, we get 3 plus 3i plus 2i plus 2i squared in my denominator, sorry, my numerator, and underneath I'm going to have 1 minus I squared. Simplifying, 2i squared is negative 1, so this is negative 2. So I end up with 1 plus 5i over 1 minus I squared, which is 1 minus negative 1. So we end up with 1 plus 5i over 2. Okay, I'm going to do a few more examples before I set you loose onto 3G. It's probably worth going through these. I've got that example there and then that one. But at any time, if you want to stop this, go and get a little bit of practice. However, 3G does kick straight into it, does get straight into division. There's no sort of breaking up as I've been able to do in previous exercises. So I'm going to work through part A here, and maybe you would like to do what we've been doing, watch A and then do B and C on your own and check back. So let's do A together. Z1 over Z2, so I've got 2 plus I over Z2, which is 2 minus 5i, and I'm going to subtract 3 lots of Z3, so I'm going to subtract 3 lots of negative 1 plus 2i. Okay, what do we need to do? Well, this fraction here needs sorting, so I'm going to have to multiply by the conjugate, so it'll be 2 plus I over 2 minus 5i. I'm going to multiply this by 2 plus 5i over 2 plus 5i. Then I'm going to run this negative 3 through, so it'll be plus 3 minus 6i. Okay, let's deal with this multiplication. Right, 2 2s are 4 plus 10i plus 2i, so that's plus 12i. And then it's plus 5i squared negative 1, so it turns out to be minus 5. Now underneath I'm going to have 2 times 2, I'm going to square my 2, and then it'll be minus 25i squared being negative 1, so plus 25 underneath, plus 3 minus 6i. So what do we got? We got 12 minus 1 plus 12i over 29 plus 3 minus 6i. So putting this all over 29, we get minus 1 plus 12i plus 87 minus, what's that, 180, 174i all over 29. Now, the real parts, minus 1 plus 87, so that's 86. 12 minus 174, so minus 162i over 29. 29 is prime, so that's about the best we can do there. Okay, that was pretty heavy. How about we look at B, and invitation to just go ahead and solve that and come back. All right, so z1 squared, I've got 2 plus I all squared over the product of z2 and z3. So this gives me 2 minus 5i minus 1 plus 2i. Okay, 4 plus 4i plus I squared, which is minus 1. 2 times negative 1, negative 2. 2 times 2i, so that's plus 4i. So plus, that's plus 5i, isn't it? Plus 5i. And we got now minus 10i squared, so that's plus 10. Alright, so we've got 3 plus 4i. 3 plus 4i over, what have we got? 9 minus 2 plus 8 is, sorry, minus 2 plus 10 is 8 plus 9i. Realizing the denominator, multiply by the conjugate, 8 minus 9i over 8 minus 9i. So we end up with 24 minus 27i plus 32i. Now it's minus 36i squared plus 36 over 8 8s are 64 minus 81i squared plus 81. Alright, what do we got? 24 plus 36 is 60, minus 27 plus 32 is plus 5i, and that goes over 145. Looks like 5 is a common factor here, so 12 plus I over 29. Okay, so C, look, I really encourage you to do C yourself and then just come back and check your answer. And really, you'll only need to play this through if you need some kind of clarification. But I'm going to run it through just in case there's one or two of you that would value that. 2z1 becomes immediately 4 plus 2i minus, now I'm taking, I'm subtracting 3z2s. So that's 6 minus 15i, 3z2s. And I'm placing that over the product of z1 and z3. So it's 2 plus I, and z3 is negative 1 plus 2i. Okay, what have we now? 4 minus 6, so I've got minus 2 up on top. 2i minus negative 15i gives me plus 17i. And underneath I've got negative 2. Now I've got plus 4i minus I, so that's plus 3i. Does that look right? Yep. And then I've got 2i squared, so that's minus 2. So negative 2 plus 17i over negative 4 plus 3i. If only that were it. We now need to window dress a little bit. Minus 4 minus 3i over minus 4 minus 3i, and realize our denominator. Negative 2 times negative 4 is 8. Plus 6i minus 68i. So plus 6i minus 68i. Now I've got minus 51i squared, so that's plus 51. Over negative 4 times negative 4 is 16. And now I've got minus 9i squared, which is plus 9. Minus 9i squared, I squared is negative 1, minus 9 times negative 1 is plus 9. So we have 8 plus 51 is 59. 6 minus 68, so we've got minus 62i over 25. And our final example, again, feel free please to solve this. We're going to find z. We're solving for z. It's a complex number. Don't get your z's and 2's mixed up here. Be very careful. I've got a z here and I've got a z here, so I'm going to make sure I've got my little dash through my z. So I've got, just in cross multiplying now, I've got z plus 2 by 2 plus I equaling z minus 3i by 1 minus I. Okay, off I go. Therefore, I've got 2z plus iz plus 4 plus 2i. That's equal to z minus iz minus 3i plus 3i squared plus 3i squared. So that's minus 3 plus 3i squared. All right, so we want z, so we're going to pull our z's onto one side. 2z, I'm going to get this z across here, so I've got z. Look at what I got here, 2z minus z, so I've got z. I've got iz plus another iz, so that'll be plus 2iz. Everything else can go over the other side. I've got on the other side, I've got minus 3i. I'll take a 2i across, so I've got minus 5i. I've got negative 3. I'm going to take another 4 across there. Take the z out as a common factor. I'll get 1 plus 2i in here. And over this side, I've got negative 7, just changing the order so that I've got real first. And now z is equal to minus 7 minus 5i over 1 plus 2i. You know what we're going to do now. It's what we've been doing all day. Multiply by the conjugate. Multiply by the conjugate. All right, lots of that sort of work going on. Right, let's make sure we're really accurate here. Negative 7 plus 14i minus 5i. No mistakes now. Plus 10i squared becomes minus 10. 1 times 1, now it becomes minus 4i squared, which becomes plus 4 when I squared is negative 1. What have we now? Negative 7 minus 10. So negative 17, 14i plus 9i over 5. All right, let's do exercise 3G now. Questions 1 to 5 are pretty standard questions. Really what we've been looking at in the examples, I think. But then questions 6 to 8 are looking a little bit different, perhaps. Yeah, certainly 7 and 8. We're looking for proofs. So what we might need to do in our Zooms is have a look at those together. But have a go, and I'll see you soon.